this matrix would have gone, would have had 2 rows. Okay. So, the idea, okay, is to have a structure of neurons, or better, is to have a network of neurons which are organized in layers, okay, and to have this propagation of the information, okay. Of course, I mean, we will see, I mean, about the weights, because we have to define these weights, right? And we will see this afternoon, which is the idea that govern the weights, okay? Actually, it's a process exactly as we do with our brain. Okay, so we learn, we need time to learn, right? Because, I mean, if you think, I don't know, to a small child, it takes time to learn things. It's the same for a network, okay? So, we will see it later, but of course these weights at the beginning are something which is random, okay? Exactly as, I mean, if you think to a small child when he born, he comes to life, he doesn't know anything, he has no knowledge, okay? So it's a kind of random initialization, okay, of weights. And then time after time he learns things. And so the network at the beginning has some random weights, but then she is able, the network is able to learn, okay, and to adapt these weights to get the best output, okay? But we will see how. Okay? So you have this first phase, which is the forward propagation, okay? Where you have an input and then you have information which is transmitted layer by layer until the output layer. Now, as I said you, okay, if you want to say you do deep learning, okay, you can use more than one hidden layer, like in this case, okay? So here we have a structure where we have 4 layers. As usual, we have one input layer, one output layer, okay? And then here we have 2 hidden layers, okay? Here we have 3 neurons, here we have 2 neurons, and so on. And in the output layer, we have 1 neuron, okay? There is no, I mean, we can have more neurons here, and we can reduce the number of neurons here, or the opposite, doesn't matter. This is why, I mean, I said you, then defining the structure of a network is not easy, okay? Because you have to define many things. The first thing you have to define how many layers, how many neurons for each layer, okay? So what is called the architecture of the network. So here, so we will have the weights from the input to the first hidden layer. Then we will have the weights from the first hidden layer to the second hidden layer. Then we will have the weights from the second hidden layer to the output. Okay? And this is how the information is propagated. Okay? Yeah.
When I have more than one sample,
yeah,
the structure of my neural level is it's the same for all my samples.
Yeah.
So you define this
I define the structure here,
yes.
and then samples are presented, are input, are given all together to the network.
Yes,
Okay.
but when you have more than a whole data set,
Yeah.
yes, how the neural network define
All the samples enter in the network, okay, and all the samples contribute at the same time at the changing and the update of the weights. But we will see it later. Okay, so you input all the samples together. Okay, and so you have, of course, for each sample you will have different activations. Okay, because this depends on the sample you input, but then the neural network is able to take all these, to process all this information from all the samples. Okay. Remember that these activation functions goes from 0 to 1. Okay? So formally, all these activation function, okay, so the output you get from the logistic functions goes from 0 to 1, okay? And the output here, the output will be between 0 and 1, okay? As we have defined the logistic function. So, how can we use this stuff for doing classification? Because I said you that this type of neural network back propagation are used mainly are used for supervised modeling, okay, and they are used a lot for classification, okay. So we can use it in this way. Let's say that we have 4 classes, okay. For example, here you want to do a classification based on images, okay, and you have different type of images, so pedestrian, car, truck, or bus, okay. Each one is a different class. So we have seen, I mean, so far with random forest and especially with super vector machine binary classification, which means 2 classes. But I mean, of course, you can deal with multi-class classification, so more than 2 classes. Okay. Which is the how do you do that? You code the class, okay, with the binary vectors in this way. Okay. So if you have, I don't know, 10 classes, for each sample you need a vector with 10 dimensions, okay, with just unit value corresponding to the column of the class he belongs to. Is it clear? Okay. So if this is class 1, then all samples belonging to this class will be coded like this. If this is class 2, samples will be coded labeled like this, 3 and 4. Okay? Then here we have a neural network. Okay? We have the input layer. Again, here we have some hidden layers with some neurons. Okay? And then we have the output layer. But in the output layer, we do not have just one neuron, we have 4. Okay, so we have 4 outputs. And these outputs, okay, corresponds to the 4 classes. Okay? Now, I said to you that classes are labeled as 0 or 1, right? Okay. And I said to you that as output, okay, from the network, we get some values, some predicted values, which are the result of the logistic function, which are values in between 0 and 1, right? So, let's say that we get a new sample. Yep. So let's say that we have trained, so our network has been already trained, okay? So we used a training set of samples to train the network. What does it mean? To update the weights, okay? So the network has learned how to distinguish pedestrian, cars, truck, and bus, okay? And then I have a new sample, okay? I don't know to which class it belongs to, okay? So the network, the sample entered in the network. The information is propagated until the output layer, okay? And here we get some predictions, okay? In between 0 and 1, okay? Because all these output layers receive the logistic, the activation function, which is a logistic activation function, okay? From the previous hidden layer. So imagine that for this sample we get here a value in between 0 and 1, so a value equal 0.01. Here a point value of 0.1. Here a value of 0.9. And here a value of 0. Okay? These are the prediction of our network in between 0 and 1. Okay? So, looking at this value, we could say that this sample belong to, probably is in class is a truck. Okay? And then in that way we have a prediction. Okay? Yeah. So now, we have seen how the information is propagated. Okay? What we miss to do is to see how the weights are updated. Okay? Because I said you, at the very beginning we have a lot of weights, right? And at the very beginning these weights are pure random numbers. Okay? Because the network has to learn from the samples. So how these weights are updated? Okay? How these weights change in order to adapt, okay, to the data that you input. So there is a process which is called backpropagation, because imagine at the beginning all these weights are random numbers. You input all your samples, okay? The information is propagated, but then here, okay, the network can check the actual output that has been calculated with respect to the real classes of your samples, okay? And on the basis of the error you will get here, then it makes a backpropagation, which means that it goes back and it transmits back the information to update the weights, okay, in order to get better predictions. And then you go up and down, then you again do a forward propagation and back, forward and back, okay? And in this way, you update, okay, the weights, okay? So there is a iterative process which update the weights in this way. We will try to see it in the afternoon. If you want, there is a very comprehensive tutorial about back propagation. It's it's on ChemoLab, Chemometrics and Intelligent Laboratory System. This is from '93. Okay, so it's not new. Okay, '93 means more than 50 years ago. Yeah. Okay. So if someone say, "Hey, I'm doing neural networks, it's a new stuff," blah blah blah, it's not. Okay. And this is very good. I mean, it's very comprehensive. It's very long, but it describes in details. Okay. The structure and the idea of back propagation neural networks. So if you are interested, it's a good option. Okay. I could, some of the slides are taken from this because it's really full of information. Okay. Do you have questions? No? No?
I still, no, sorry. I will have a way, okay. Imagine that I have a second sample, okay, with the same variables, okay. I will have a weight with the same variable with the same neuron.
No, but we will see that samples are so.
Okay.
When you update neural networks, this is also true for the other type of neural networks, but you can introduce one sample at a time, but it takes ages. Or you can do what is called the batch training. So you input all the samples together in the network. So at the end, it's you use matrix computation. Okay, so you can input all the samples together, and you can get at the end the update of the weights on the basis of all samples. Okay? We will try to see it in the afternoon. Because it's, what time is it? Yeah, so I think it's, it's better to have a break now. Okay? And we can start again, I don't know, at in 1 hour and a half. It's okay for lunch. Okay? Okay.
No.